This is a recording of part 1 of the lab experiment on capacitors and RC circuits. I'm going to be using the vernier circuit board that the folks that do this lab in class are using. Obviously, if you're watching this online, you can't do that, but you can observe the video and then use the data that we collect to do the analysis part of this experiment. So the first question we're trying to answer is, how does the current through an RC circuit change with time while the capacitor is charging and discharging? Well, we can't easily see current. We can put a current meter into a circuit, but there's another way we can see the effects of current, and that is to use a light bulb in a circuit as a resistive element. So we're going to build this circuit that's diagrammed on the lab handout using our vernier circuit board. So I have a circuit board that has a battery case in the upper left corner. We're going to go ahead and add the batteries to that part of the circuit. And then if this little switch down here is in the upper position, the 3-volt setting, it provides power to the two pins that are here, top and bottom, positive and negative pins 31 or 35 rather, and number 1. I'm going to flip it down to the external just to shut that power off while I build the rest of the circuit. The switch that we're going to be using in our circuit here is a double throw switch, and it allows us to connect essentially two different circuits for two different purposes, and we'll see what those effects are as we move through this experiment. So I'm going to go ahead and wire up the circuit diagram that's shown on that page. You can also get some step-by-step directions a little bit further down in the lab handout. So we want to first connect the positive end of the battery to one end of this double throw switch. So I'm connecting pin 1 to pin 32 here. I'm going to then connect the 33, so sort of the out part of one part of the switch, to the left side of my light bulb, and the light bulb here is acting as the resistor in my circuit. I'm going to then connect the other side of the light bulb to an external capacitor, and here I'm using a capacitor that has 4.7 farads of capacitance, much more capacitance than the built-in capacitor on the circuit board, which has 10 microfarads. We'll use that one built in for the second part of the experiment when we're collecting some data. So I'm going to go ahead and just clip that on to one side of the capacitor, and then take the other side of my capacitor and wire that back to the negative connection to the battery, which on this circuit board is pin 35. So that's the whole outer loop of that circuit diagram that's diagrammed in the lab handout. But now I need a discharge loop, that is a loop that doesn't contain the battery. And so that's where this double throw switch comes in. If it's in the upper orientation, the battery is part of the loop, but in the lower orientation, it connects this pin to the lower pin here, excludes the battery, and we're going to go ahead and take that lower switch pin, pin 34, and connect that to the negative terminal of the battery, which is pin 35, and I now have built the circuit that's diagrammed on the first page. So question 1 tells us to flip switch S2 to the upper position in order to charge the capacitor and observe what happens to the bulb in the circuit. So I'm going to go ahead and turn on power by turning it up to the 3-volt setting, and then flipping this on, and we want to focus on what happens with the light bulb. So you can see the light bulb went on, just like it would if we built a circuit with only the battery and a light bulb and no capacitor, but now we want to watch it over a little bit of time. So you may notice, and I hope this is coming through okay on the captured video, that the brightness of that bulb filament is decreasing with time. It's getting dimmer and dimmer. And we use that as an indication that there is less and less current flowing in the circuit. So number 2 asks, what do the observations suggest about the current in the circuit as a function of time? Well, if the bulb filament brightness is any indication, that is decreasing as a function of time. And it asks you to try to sketch a graph of current as a function of time. I would encourage you to do so. We'll be making a measured observation in part 2 of this lab, which will allow you to check your intuition with what we actually measure on the computer. I can still barely see the bulb glowing. And as it says in question 3, let this run for at least 5 minutes. Because it turns out that even after the bulb is no longer visible, there's still a small bit of current flowing in this circuit, and the capacitor is charging up during that time. So we're going to let this thing run for 5 minutes. If you're watching this on the video, feel free to go ahead and fast forward a couple of minutes to when we do the next part of the experiment. All right, it's probably been about 4 or 5 minutes since we first did this, so I'm going to move on to step 3. It says after switch S2 has been in the upper position for at least 5 minutes, flip the switch to the lower position, and recall when we flip it to the lower position, that's going to exclude the battery from this circuit. But let's observe what happens with the light bulb. Hopefully you were able to see on the video, but the light bulb went back on. It appeared to be approximately as bright as it was when it first was connected to the battery, but the battery is not even part of this circuit anymore in the way this is wired. I can demonstrate that to you. We can go ahead and even take the batteries out of the holder, and my light bulb is still on. The light bulb in this instance is being powered by the charges that have been stored on the capacitor. But we notice that, like the first experiment, the brightness of that filament is diminishing over time, and that's telling us that the current flowing through this loop is decreasing over time. Again, it encourages you to try to sketch what you think a graph of that current might look like as a function of time, and I would encourage you to do so. And also to think a little bit about question 5, that asks you to try to explain what you think is going on in this circuit in terms of the observations that we're making. Now, if you're doing this online it might be super helpful to jump back to the capacitor lab on PhET and play around. They have one half of that simulation that involves connecting a light bulb, essentially building this circuit that we're building right here. And that may be helpful for you in visualizing what's happening in the capacitor during this time. I'm going to let this thing keep running on my desk, but I am going to stop the video. There's not much exciting things to see here. I can still barely see the filament on, but its brightness is diminishing over time, and if I let this stay connected for long enough, it will eventually go out, and eventually the capacitor will be fully discharged.